This is 10.1.1. We're going to take a look at parent functions and amplitude. So we're going to identify the parent functions for sine, cosine, and tangent, and understand the amplitude of trig graphs. So we're going to basically add our different trig graphs to our list of parent graphs, things we need to memorize. Now, in order to graph sine, cosine, and tangent functions, we're going to need to utilize the unit circle. And we use radians. It's just a little cleaner as the axis points. So we take the poles, 0, pi halves, pi, 3 pi halves, etc., and we use those as our x values on the unit circle. And you can go in the negative direction as well. And then what ends up happening is, if you think of it as like sine of x or cosine of x, right? And in this case, I did y equals cosine of x. Well, your input is 0. Well, the cosine of 0 is 1. So I could create a table. If I plug in 0, I get 1. If I plug in pi halves, I get 0. If I plug in pi, I get negative 1. If I plug in 3 pi halves, you get 0. And if I plug in 2 pi, you're going to get 1. And you can obviously go into the negative direction as well. And if you want to connect it, you get this curve, and we call that our cosine parent graph curve. Just remember, these important values are 0, pi halves, pi, 3 pi halves, and 2 pi. Those are the important x values. We can do the same thing for sine. If I create the chart and I plug in 0, you get 0. If I plug in pi halves, you get 1. If I plug in pi, you get 0. If I plug in 3 pi halves, you get negative 1. If I plug in 2 pi, you go back to 0. And so you can go in the negative direction, and then when you sketch it, we get our sine curve. Now, just to note a couple of things, the domain is always negative infinity to positive infinity. Even though we may only draw a couple of cycles, it goes on forever. Okay, so that's really important. The ranges of our parent graphs are between -1 and +1. It's continuous and smooth. Going back to our identities, cosine is considered an even function, sine is considered an odd function, and these parent graphs have a period, meaning one cycle. This is the idea of one cycle is 2 pi. Now, all of those ideas can change, right? We can manipulate it, but these are just for the parent graphs. So just like with any other function, we can actually modify and transform our trig functions with something called an amplitude. So I'm just going to rescale it, okay? Because if you look at, it's at 1 and at -1, all I did was just rescale it. Now, if I multiply my function by a number, let's just say this number is a, what it actually does is it stretches my function vertically. Okay, it's a vertical stretch. Now, in sine and cosine functions, we call that the amplitude. The amplitude is the distance from the center line to the highest and lowest value on our graph. And so since the distance is going to be 5, my amplitude is going to be 5. So in this instance, because there's a 4 in front, I could say that my amplitude is 4. And so with my parent graph, starts at the center line, goes up to the amplitude, crosses the center line, goes below, goes back to the center line. And again, if you think of those important values, those x values that I told you to know, 0, pi halves, pi, 3 pi halves, and 2 pi, you could just take those values and plug them in. If I plug in 0, sine of 0 is 4, or sine of 0 is 0. 0 times 4 is 0. Sine of pi halves is 1. 1 times 4 is 4, right? You can create those values by creating your x and y table. You can do the same thing with cosine of theta. So that 6 tells me my amplitude is 6. And so with my cosine parent graph, if I were to plug in 0, cosine of 0 is 1. 1 times 6 is 6. And so that's why it starts up there. Now you could also have half. It just means your amplitude is half. That's a vertical compression. So I took my graph and I'm pushing down on it instead of pulling on it. And so we just have our amplitude of 1/2. Now here's a tricky thing. Amplitude can't be negative. The distance of something cannot be negative. So even though this says -5, we need to do two things. The first is that negative means a reflection over the x-axis. And then that 5 then tells me my amplitude is 5. So the negative, we have to separate it. It means reflection. So this is the reflection replied. Normally, the graph does this. But because we have that negative there, it got reflected down, it got reflected up. Now let's take a look at tangent. Remember, tangent is sine over cosine. So if I kept doing sine over cosine throughout these important values that I mentioned, 0 over 1 is 0. 1 over 0 is undefined. 0 over -1 is 0. Now I'm down here, -1 over 0 is undefined. And if you keep following that pattern, it just goes on forever with these dots and asymptotes. Now if you go through and you actually plug in the values, our tangent graph looks like this. So the important values for one cycle is going to be from 0 to pi. And we say dot asymptote dot. So it's just a funny joke, but who helps us graph tangents? Dad does. Dot asymptote dot. Once we just know that pattern, it's actually very easy to graph tangent. So if I said 10 tangent of theta, here's one thing to understand. There's no amplitude for tangent. Okay, so there's none. There's no distance. If I have this image here, there's no distance from the center line to the highest value because it goes up and down forever. So therefore, there's no amplitude. But with tangent, for those important values, 0, pi halves, and pi, dot, asymptote, dot, all you have to do is just sketch that pattern. Now, what does that tend to? That 10 does pull on our graph. Okay, so it does have this little stretching effect, but it's kind of hard to indicate on the graph when we're trying to sketch it. So what did we learn today? We talked about graphing sine, cosine, and tangent. The important values for sine and cosine are 0, pi halves, pi, 3 pi halves, and 2 pi. And then for tangent, it's just 0, pi halves, and pi. The parent graphs, sine of theta, starts at the center line with the first important value, then goes up to the amplitude, crosses the center line, goes below, goes back. Cosine starts at the center, or starts at the amplitude, crosses the center line, goes below, crosses the center line, and goes back. So this is for one cycle. And then the tangent, dot asymptote dot, is what we need to memorize to be able to graph this. And then the amplitude, that is the distance from the center line to the highest and lowest value. This does conclude our lesson. If you have any other questions, please leave them in the comments.